React enthusiasts, are you ready to dive into the wonderful world of state management? If you have got the basics of HTML, CSS, JavaScript, and React under your belt, you are in the right place. This course is designed just for you. Now, let's talk about what we'll be covering. We are going to explore a variety of state management patterns to make your React apps more efficient, robust, and just plain awesome. Here what is on the menu. First, we'll be learning about managing state with hooks. We'll kick things off with the basic classic hooks like useState and useReducer. It's like React secret sauce. Second, context API. Next, we will dive into the context API, perfect for when your state needs to travel far and wide across your app. Think of it like the magic carpet ride of your data. Third, recoil. Then we'll introduce recoil. It's like the cool new kid on the block. Recoil is a powerful, flexible, and ready to simplify your state management. useState. Finally, we'll wrap things up with useState. It's a lightweight, easy to use, and packs a punch like the superhero of state management libraries. Get ready for this series packed with fun, laugh, and plenty of aha moments. So grab your favorite coding snack, sit back, and let's make state management easy as a pie. Alright, React users, first let's chat about why state management is so important. Okay, I will make this one very short. I will try to understand it later by coding. Now imagine you are building an epic app, a unicorn of a project. As your app grows, managing the state, the data and how it changes over time, become like juggling a flaming torches. So without a proper state management, things can get really chaotic very fast. Now, imagine trying to keep track of user inputs, API responses, and those all sneaky little bit UI updates at all once. It's like herding cats, adorable but impossible. Good state management makes your life easier by keeping things organized. It's like having a tidy desk where you can find everything you need. You know exactly where your data lives and how it is supposed to behave. Reducing bugs. Fewer bugs means fewer headaches. Proper state management helps you avoid those annoying why is this not working moments. Improving performance. With efficient state management, your app runs smoother than a butter on a hot pancake. No more sluggish interfaces or slow responses. Making your code readable and maintainable. Your future self or anyone else who works on your code will thank you. Clear, organized state management means less time deciphering spaghetti code and more time building cool features. So think of state management as your app backbone, giving it structure and stability. Now let's dive in and start learning the state management in React, and we'll start with the first pattern which we'll be using built-in hooks in React, and we use a method called useState. And what is a better way to learn than just by creating a fun game called clicker game? Okay, so first, maybe you're wondering what is this useState? The useState is a special function in React that helps us keep track of things. Think of it like a sticky note that you can update whenever you need to. In our This Clicker game, we will use this useState to help us keep track of the score. So at the moment, I have a shell of my code, and you can see we have a score displayed right here. Okay, and we have these buttons, and what we want is that whenever I click, for example, this button, I want to increase my score, and if I click this one, I want to decrease it, and if I want to reset it to whatever initial value, I want to be able to do that, which means this value we need to track it somehow. It needs to be dynamic. At the moment, it is hard coded. It comes to small things that you need to track within your components, which you don't need to access somewhere else. That's when we use the useState hook method. Okay. Now, what we will do is that first we need to import this useState from React. So I'll come up here, I'll say import use state. And by the way, I'm using create React app if you're wondering as a boilerplate for my application. So I imported my use state, and this use state, it will help us to access two things. The first thing is the value of our state, and the second thing will be a function that will help us to update it whenever we want. And one more thing you have to keep in mind that useState, it is a hook in React and you only can call it within your functional component. If you have a class component, you can't use this. So we'll go and create our state and you can call your actual state any name you want, but usually you have to be meaningful when you're making namings, okay? So I know I'm tracking a score, so I will call my state score. Okay, or call it score state or anything you like. So I'll call it score. Then the second thing will be a function that will help me to change this state. Okay, and usually it starts with set and any name you want. The way I do is that I do set and the name of actual state. So when you have bigger applications and so many states, it's easy for you to know which function is for which state. Okay. So now we try to access our use state and by default it will accept a value, okay? So you can give it a value if you want and if you don't want to, you don't have to, but I will give it a default value of 0, okay? Now what I will do, I will try instead of hard coding this 10, I will just pass on my state to display it in my UI. Let's save this and there we go. So our first step is done, okay? We created our score, which is our sticky note with the current score, and we started with 0. And also we have set score, which is like our pen to write new numbers on our sticky notes. Okay, we can take it this way. Now, let's see the next step, which is creating functions that update our score, okay? And we will need some buttons, which I already added to change our scores, and we will be triggering these functions assigned to it. So let's see the first button, which is increase. And I have here a button with a function called increase score that I defined. Now all what I have to do is that when I click this button, I want to increase my score with 1. So the way we can do it, we call this setter function inside. And then you can say, I want to increase my current state with number 1. So score plus 1. Okay, same thing I will do for others. So this is decrease, which means what I want to do is I want to decrease whatever my current score with 1 as well. So set score minus 1. And the reset one, I think now you might have idea what you'll do. We want just to reset whatever the initial value we had. So again, set score, but we reset it to 0. That is the start number. Okay, now let's save and let's test our UI. So click increase button and you can see it's increasing. I click again and it's increasing. Decrease and reset, which is resetting to 0. And there you have it. You have just created a clicker game using useState. Now, every time you click those buttons, you are using React useState hook to keep track of your score and update it. It's like magic, but for code. Oh, this is very simple, very easy, right? All what we have is just very simple clicker game. We have one value that we are tracking with very simple actions. Okay, we're just increasing by 1, decreasing by 1, or resetting to our default value. Let's say, for example, you want to grow this game, okay? Make it more outstanding, more complex. You want to add extra mechanisms to it, okay? Like double points, half points, and do some action, do power apps or penalties, things like that. So these are very complex mechanisms you want to add, and it will be difficult for you and it will not make sense for you to track it within a simple state like use state. Okay, so use state is just for simple tracking of some information that you want to change also in a very simple way. But when it gets very complex, it goes out of control here. So we need to use a different state management to handle it, okay? And React have another built-in hook which called useReducer. And useReducer is also used for state management, but a little bit more complex ones. And let's start working with this. First thing is that we remove useState and let's refactory to introduce useReducer. Okay, then it works almost the same way as well. Okay, so we'll come inside here and we'll try to access properties from useReducer. So we'll just say useReducer. It will give us also two things. The first thing will be your current state. Okay, and the second thing is also a function. And this function will help us to trigger the actions we want. Okay, and we'll see later how to do that. Now the user reducer itself, it accepts two arguments. Okay, your actual reducer that we will have to create and the initial state. So what will be your initial state? Okay, so it looks a little bit similar to useState, but you will see that we can do with this user reducer much more complex actions and handling. Now we remove this. Now we'll come up here and we have to declare our reducer and also we have to declare our initial state as well. So step 1, initial state. So let's define it, const initial state, and that will be an object, and that object will have a property called score, and we will give it 0 as we did before as well. So this here you can create again these values and name them anything you want. Okay, now we defined our initial state. Let's define the reducer now. Okay, which is your step 2. So the way we do that, we just say const and reducer. So whatever name we said here, that's the one you're declaring there. Okay. And that reducer, by default, it will be taking two properties, okay, or arguments. First is your current state, whatever the state you have. Then something else called action, okay? And action, it will help you later. We'll see later how you can use it. So whenever you dispatch an action, it will have something called type that will know which action you should be triggering. Okay, so this will sound a bit confusing, so we'll take it step by code, which will make more sense. So it accepts two properties, state and action, and then you'll have a switch method. Okay, and this switch will be depending on this action dot type. So we said this type of action will be an object, and each object will have always a type, okay? That we'll have to check. And depending on that type, we'll be doing different things, okay? So let's say case number 1, we have increase. If you remember, we have increase. So we'll call it increase. You can call again this thing anything you want, but whatever string you use here, you have to use it later, okay? Now, if it is increase, now we'll tell what it has to do with the state, okay? So say return, spread operate your states, okay? So whatever you have in current state, I want you to return it, but with a little bit difference, where the score state itself, I want to change it to state to score +1, okay? Exactly what we have done there, we'll be doing here. And why we did the lane 13 here, let's say for example you have a complex state which have score, it have, I don't know, name of the player for example, okay? You have maybe history of the scores for example, 0, 1, 10, okay? So what I want to do is that if I have any other states within my initial state, I don't want to go and remove them by mistake, okay? Because your real applications grows by time and things can be added. So I'm saying whatever my initial state in the reducer, spread it, then pick up the score and increase it by 1, okay? And that's the reason for lane 13. Now let me remove this because I don't need them. So that's our for first case. We'll do again same thing for the decrease and reset. So we come here and we say case. Again, call this string anything you want. I'll call it decrease. And when I have this decrease, I will do return. And again, spread operate my state, but change the score to state.score -1. Okay. Then now reset case reset. And again here what we'll do, I hope now you know what you'll be doing by yourself. So return, spread, operate your state, and then score will be 0. Okay, and always you should have a default return in case someone call this reducer action without any of these strings, okay, with something different. So everyone handle it differently, but for this time we'll keep it simple. Just return whatever my current state is, okay, no changes. So now we created our reducer, okay, we have our initial state. Now how we can trigger this reducer, okay, or even how to access it. We'll go back to our component, and here we created, remember we try to access the useReducer. So we have the state and we have dispatch, okay? Now what you can do is that when we click dispatch, I can just trigger it here. When I click increase score, I want to go into dispatch, and this dispatch, it is your action now, okay? So this dispatch will have an object and it will have type of increase. So what we're saying dispatch from an action, which is this action. Okay, that's how it gets linked to your user. Dispatch this action, okay, with a type of increase. So what we'll do in this one triggers, it will go check your reducer that we defined up here, and then go to the switch method and check for the type. If it's match, which is for us in this moment, it will go and update our state score with 1. Now same thing we will do with others. So we remove whatever code we had before, and our just second will be decrease, and the last one will be reset. And you have to be careful because of strings to not do any spelling mistakes. Let's save this, and this is not working, and reason why, because I'm still accessing the old state, which was score. Now I have to do state.score. Okay, whatever state name I give here, that's the one I'm accessing here, .score, because if you remember, we declare our state as an object. Okay, now let's save this. And there we go. So the first initial is working. If I go to increase, it's increasing. If you go to decrease, it's decreasing. And also if you want to do reset, it is resetting for me. Now you'll be thinking, okay, same thing I have done with useState, and we are doing the same thing with useReducer, but just more complex. Well, this is just a refactor what we have done before to show you how you can do it. But as I told you in the beginning of this chapter, is that this is just a simple demo, okay? You may have different functionalities. You want to change, for example, the method of your scoring. You want to add penalties. You want to add history, all these things. Even maybe you have this component in one screen, but you want to access the same one from another screen, okay? And pick up whatever the state you had before. So this, when you use the reducer, comes very handy and help you to manage this difficult state management. So this was just a presentation. I have a full video on useReducer within my playlist of useReducer hooks. So feel free to go and check it as well to help you to understand better on how to use this useReducer. Okay. Now we mastered a little bit how we can use a useState, and we rocked with the useReducer. But let's say if our game even gets even bigger with more components, okay, like a leaderboard or power apps and settings, passing data through all these components can get really messy. And that's when the context API comes to our rescue. So now imagine you're running a restaurant and you have one special dish, which is our score, that every chef needs to know about it. Passing the recipe, which is the state, from one chef to another props can be slow and confusing. So instead, you put the recipe on a big whiteboard, which is the Context API, in the kitchen so all chefs can see and use it whenever they need to. So now let's break it down a little bit. With useReducer, we centralize our state logic, but if many components need to access that state, passing it down through prompts can be really confusing and risky as well. A lot of performance issues. And also that have a name which calls props drilling, which you don't want to do, trust me. Here, Context API acts like a global state accessible by any component, making it easier to share and manage the state as well. So now this context, it have two steps. Okay, first you have to create the context, which will be like our big whiteboard where everyone can see the score. And the second step will be creating a provider for this context. This will wrap our app and make the score available to all the components. Okay, now this is a lot of talk and explanation, so let's see how we do it. Back to our code. So up to last chapter, we had all this code in the app.js. So all what I have done, I created a new component called game, and I moved all that code in there. Okay, our user reducer is there. So you can see it's still working. Okay, so if I decrease, reset, everything's working, it's fine. The extra thing I did is that I created another component which called leaderboard, and I want that component to access my score, which up to now, if you can see, leaderboard is separate from the game. It's different piece of code, it's a different component. That's where Context API will help us to get this component's ability to access my state in the game component. So this way we avoid this prop drilling. Okay, we don't want to do the case where you take the state, pass it up to app.js, sort in some state there, and then my leaderboard read it from there. Okay, that's can be really buggy at some point. So we don't want to do that. Now, first things first is that we need to create our context, which we said will be our big whiteboard that everyone can see to score. So we'll go and I'll just create a new file. Okay, and this file again, you can call it anything you like. Okay, but again, stick to some meaningful namings. So I'll call it game context. Okay, .js. Now, what I will do here, first I'll import React, and we need to import two hooks as well. So first one is the useReducer that we have up there, because we will move all this logic to our game context. So use reducer. And the second one will be the create context. That we said our first step to create our whiteboard. Okay. Now, the second thing is we need to initialize our context, okay? So we'll create our whiteboard. Export const game context, and you can call this anything you want as well. And we'll access our hook create context. There we go. So our board now is created. Now let's try to fill it up, okay? So all what we have to do is just move whatever code we have here. So I'll copy all this and paste it right there. Okay, and then we will create now our provider, which is kind of a shell component. Okay, export const game, and you can call this again anything you want, but just for consistency, I'm keeping the game, and then I have context, and I have here to be provider. My spelling is wrong, provider. And by default, it will accept some elements as children, and you'll see later why. And here again, we will move whatever code we have here. Okay, so we have this initialization of our reducer. I'll move it right there. And then we do return. And our return, we will have game context. Okay, so the one we created right there. And we can access something called provider. Okay, and then inside we will render our children elements. Okay, now this context game context provider, it accepts one property which is called value. And here basically you can pass anything you want, okay, anything that you want other components to have access to it. So we know we want to access the state and also dispatch, okay. So I'll give this one an object and state, and it will be a state and dispatch, and that will be dispatch. Now this is confusing. This is the name I'm giving, okay, and this is the state from here. And dispatch is the name I'm giving to my property in my object. And this dispatch here is the one I'm getting from useReducer. And because they have same name spelling, so I can just give a shortcut here. So I don't have to do that. Now what we have done is that we created our context. Also we created our whiteboard. But at the moment it's just hiding somewhere. It's not used in anywhere. So we have to access it. So we need to go back to our game component and we'll import our game context. Okay, so import game context that we created, and we can go now inside our game and we'll try to access the values we passed here. Okay, so const state and dispatch equal to use context, and we have to import that hook now. Use context, which will help us to use the context we created. Okay, so use context, and then you pass the context that you created, game context. Great. Now we created our context, we said which values we need, and also all that functionality of updating the state and triggering the actions, all are managed by my context. Okay, then I make my whiteboard, I pass all the data to it, but now I just want to use it. Okay, so that's what I'm trying here, use context, and I'm importing the context I created. Then I'm just declaring here, I'm accessing the values I'm getting back. Now I'm free to go and use it wherever I want to. Okay, so lucky for us, because we use the same namings we had before, so we don't have to do much. Okay, so the game board will work still. So if I save, I can see here this one is failing. That still will not work. Reason why is that because we didn't make this context yet available to all our application. So we have to go to the source where it's a wrapper for my both components. I need to import the provider I created here. Okay, and I will wrap up my components with that provider. So, oops, let me import that provider, game provider. And then I will go here, I will just wrap all my app with that. Okay, so game provider and say my closing tag. And let's click save, and you can see now my app, at least the first screen is rendering, which means I'm able to access at least the initial score, which is the default one for my context. Okay, now let's test first this, make sure it's working. Yeah, it is working. Reset, increase, decrease. So all my functions are working. Now let's see how we can access this score from my other components. Also now it's become very easy and very simple. We just go to our leaderboard component, okay, and we will import the hook, use context, and also we import the context we created as well, import game context. Then we come here and access whatever we want. So in here, we don't need the both values. We just need the state, okay? We don't need the dispatch. We can also only access whatever we need. We don't have to access all the values at once. So we say const, I want to access the state equal, and it's use, oh, I said here use callback, should be use context, use context. And I want to access the game context. Great. Now we can just simply go here and say display my state dot score. Let's hit save and voila, it's working. Okay, so I hope now that makes sense for you. So all what we have done is that we have a separate component and we have another component. The whole interaction is happening in one, but the second one can access whatever values we want from the first one, okay? Without any prop drilling or anything like that. Now let's test it, increase. And you can see as I increase, you can see in both places increasing. If I reset, both of them got reset. And if I decrease, also both of them decrease. So there you have it. By using the Context API, we can share the game state across multiple components without the hassle of prop drilling. Our Clicker Gamer is now more organized, scalable, and ready for new features. So keep clicking, coding, and having fun.